Welcome back, everyone. Today we're diving into the world of AI, specifically something called the Segment Anything model, or as the cool kids call it, SAM.
Catchy, right.
Definitely. We're going to break down exactly what makes SAM so groundbreaking, and trust me, it's a game changer.
Oh, absolutely.
Our source material for this deep dive is some excerpts from a research paper published by Meta AI Research, so get ready for a bit of a technical journey. But don't worry, we'll keep it fun.
We'll make sure it's crystal clear.
So, first things first, could you give us a quick explainer on what exactly image segmentation is? Why should our listeners care about this?
Well, imagine you're looking at a picture, right? You automatically start picking out different objects. A dog, a tree, a car, whatever it may be.
Like describing a scene.
Exactly. And image segmentation is basically teaching computers to do the same thing. Identify and separate those different objects or regions within an image.
So instead of just seeing a jumble of pixels, the computer actually sees a car, a tree, a person, and can tell them apart. Makes sense.
Yeah, it's like giving computers the ability to actually see the world around them, understand it object by object.
Okay, got it. But why is that such a big deal?
Think about self-driving cars. They need to know the difference between a pedestrian and, say, a fire hydrant instantly to make safe decisions.
Yeah, that makes sense. Or like medical imaging. Being able to highlight tumors for doctors. Huge implications.
Exactly. Tons of real-world applications.
Okay, starting to get the picture.
Yeah.
So where does SAM fit into all of this? What makes it different?
SAM is what we call a foundation model for image segmentation. And what's really remarkable is its ability to generalize to new images and tasks. It can accurately segment images it's never seen before. It wasn't specifically trained on them, zero-shot learning.
Hold on. Sounds a little too good to be true. How does it even do that?
It's all about how SAM was trained. It uses something called prompt engineering. You give a hint about what to segment. A prompt.
Yeah, like a clue.
Right. And that prompt could be as simple as like pointing at an object in the image.
And SAM, with all its knowledge, can figure out the rest.
Pretty much. Its training data set is so massive and diverse that it can usually make sense of things even with just a tiny hint.
Okay, so it's not magic, but it's powered by some seriously clever engineering and a whole lot of data. But how does it actually process all of this information? Like, what's the secret formula?
Think of SAM as a three-part system. You have an image encoder that looks at the whole picture, then a prompt encoder that understands your hints.
Okay, 2 encoders so far.
Right. And finally, a mask decoder that combines this information to predict segmentation masks, which are basically outlines of the objects, all in real time.
Masks?
Yeah, like those coloring books.
Where you have the outlines and you fill them in.
Exactly. A mask is kind of like the digital equivalent, highlighting the object the AI has identified.
Ah, that's a great way to visualize it. So Sam looks at the image, gets prompt, and boom, creates a mask around the object.
You got it. And it does this incredibly fast. Like, we're talking milliseconds, even on a regular web browser.
Ooh, that's impressive. But what happens when things aren't so clear-cut? What if I point at something and the AI isn't exactly sure what I mean?
Well, that's where SAM gets really clever. If a prompt could refer to multiple objects, it actually predicts several possible masks.
So it has options.
Yeah, and it assigns each mask a confidence score, like saying, I'm pretty sure this is it, or this is just a guess.
So it's not just blindly following instructions, it's actually thinking things through, weighing the possibilities.
Exactly. And that's one of the things that makes SAM so reliable. You can actually see some visual examples of this in the research paper, if you're interested. Figure 3, I think.
Cool. We'll definitely link that in the show notes.
Yeah.
So we've got this AI that can segment images in real time, handle ambiguity, and is powered by some pretty sophisticated engineering.
Right. And all of that, those zero-shot capabilities, it wouldn't be possible without a truly remarkable training data set.
Oh, yeah. You mentioned that earlier, the SA1B. Tell
Yeah.
me more about that. What makes it so special?
Well, for starters, it's massive. We're talking over 1 billion masks, which is like 400 times larger than any previous segmentation data set.
1 billion. That's a lot of masks.
Yeah.
Like a mind-boggling amount.
Yeah, it's really unprecedented. And it's not just the size, it's also how they got this data.
Yeah, you mentioned that creating the SA1B was a big challenge.
Huge. You see, image segmentation masks, they don't just exist out in the wild, unlike, say, text data, which you can just scrape from the internet.
So they couldn't just download a bunch of images and their corresponding masks. They had to, create it themselves.
Pretty much. And that's where the real ingenuity comes in. They actually built what they call a data engine to create this massive data set.
Like a data engine. Sounds intense.
It was a multi-stage process. They combined human expertise with AI to really scale things up.
So human in the loop kind of thing.
Exactly. It started with human annotators, people who actually create the masks. And they had this interactive tool that was powered by an early version of SAM.
So even in the early stages, Sam was part of the process.
Yeah. It helped the annotators work much faster. Like, as Sam got better, the time to annotate each mask dropped significantly, but that was just the beginning.
Okay, what happened next?
Well, they started leveraging Sam's growing abilities to automate more of the process. So, like, in the later stages, Sam could automatically generate masks for some of the more obvious objects in an image.
So the humans could focus on the trickier stuff.
Yeah, the less obvious stuff, which further increased the diversity of the masks they were getting, and then eventually...
They let Sam loose?
Well, not completely loose, but they got to a point where a highly advanced version of Sam could generate high-quality masks for entire images without any human input.
Whoa. So they trained Sam to basically annotate images by itself.
Pretty much. And that's how they ended up with over 1 billion masks from 11 million images.
11 million images. That's a lot of pictures.
It is. And they made sure to source these images from all over the world. Like, geographic diversity was really important to them, which is fantastic.
Yeah, that's really cool. So they've created a data set that's not just massive, but also really representative of the real world.
Exactly. And here's the kicker. They're planning to publicly release SA1B.
Whoa, so anyone can use this.
Well, researchers, at least for now. But think about the possibilities. All these people can build new models, explore new applications, all thanks to this amazing foundation of data. It's a game changer.
It's like they've given everyone a treasure map or a launch pad for like 1,000 new AI projects.
Uh-huh.
Okay, so we've covered what image segmentation is. We've talked about this insane training data set. Now for the fun part, what can Sam actually do with all this knowledge? Okay, we've talked about image segmentation. We've delved into Sam's incredible training data. But now I'm really curious, what can Sam actually do?
Well, that's the exciting part, right? What sets Sam apart is its zero-shot learning.
We touched on that before. So basically, it can do things it wasn't specifically trained for.
Right. It can generalize, learn fundamental principles about images, and apply them to new situations.
Okay, I need some examples. Like, what kind of tasks can it handle?
Well, let's start simple. Edge detection. Finding the outlines of objects in an image.
Okay, yeah. So can it do that?
Surprisingly well, actually, even though it wasn't explicitly trained for edge detection.
Really? So the same model that can, like, segment a whole dog can also pinpoint the edges of its ears.
Exactly. It's pretty remarkable. And, it actually performs better than some traditional edge detection algorithms.
Wow. Okay, that's pretty versatile. But let's move beyond edges. What about something more complex, like object proposal generation?
Ah, yes. Object proposal generation, that's a key step in a lot of object detection systems. The AI is quickly scanning an image and saying, hey, there might be something interesting over here and over there.
Kind of like narrowing down the search before actually identifying the objects.
Exactly. And what's amazing is that even in this zero-shot scenario, SAM is competitive with models that were specifically trained for object proposal generation.
So even though it's doing something it wasn't explicitly taught, it's still holding its own.
Yeah, and we're not talking about just a few objects. They tested it on a data set with over 1,200 object categories. The results were really impressive.
Okay, color me impressed. What about something even tougher? Like, what about instant segmentation?
Instant segmentation, yeah, that's a whole other level.
It sounds complicated.
It is. It involves identifying individual instances of objects, even when they're touching or overlapping.
I'm not sure I follow.
Okay, think about a bowl of fruit.
Right, yeah, got it.
Instant segmentation would allow the AI to, separate each apple, each orange, even if they're all piled together.
Ah, so it's not just seeing a clump of fruit, it's seeing each individual piece.
Exactly. And this is where Sam's ability to predict multiple masks for a single prompt really comes in handy.
Oh, right, like we talked about before.
Yeah. So by combining Sam with an existing object detector model, they were able to do instant segmentation in a zero-shot setting.
How did it do?
Really well, actually. It wasn't quite as accurate as fully trained models, but still remarkably good, especially considering it's zero-shot.
Okay, now for the really mind-blowing stuff. You mentioned something about text-to-mask capabilities. That sounds like almost science fiction-y.
It is pretty wild. It's still early days, but the researchers have shown that SAM can actually segment objects based on simple text prompts.
Whoa. So, like, I could type in a wheel, and it would find all the wheels in an image.
Yeah. Or even something more specific, like a beaver tooth grill, and SAM can figure out what you're talking about and create a mask for that.
That's incredible. It's like giving the AI verbal instructions.
It is. It opens up a whole new world of possibilities. Of course, there's still room for improvement, but the fact that it's even possible is a huge testament to the power of SAM's design and that massive data set.
Yeah, the SA1B. Definitely a game changer.
Absolutely.
Well, we've covered a lot of ground today. What would you say are the biggest takeaways for our listeners about SAM?
I think the biggest takeaway is that SAM represents a major leap forward in computer vision. We're talking about an AI that can learn fundamental things about images and apply them to new tasks.
Tasks it's never seen before. That's huge.
It is, and the potential applications are vast. Self-driving cars, robotics, medical imaging, augmented reality. It's really exciting to think about what the future holds.
I know. I'm definitely going to be keeping an eye on this. Thanks so much for taking us on this deep dive.
My pleasure. We'll be sure to link to the research paper and the associated website in the show notes for anyone who wants to explore further.
Awesome. Until next time, everyone, keep learning, stay curious.